Hello and welcome back. Today we'll be doing question 8 from the 2006 Step Paper 3. Let's get started. Triangle is an operation that takes polynomials in x to polynomials in x. That is, given any polynomial h of x, there is a polynomial called triangle h of x, which is obtained from h of x using the rules that define triangle. These rules are as follows. Rule 1. Triangle x equals 1. Rule 2. The triangle of f of x plus g of x is triangle f of x plus triangle g of x for any polynomials f of x and g of x. Rule 3. Triangle lambda f of x equals lambda triangle f of x for any constant lambda and any polynomial f of x. Rule 4. Triangle f of x g of x equals f of x triangle g of x plus g of x triangle f of x for any polynomials f of x and g of x. Using these rules, show that if f of x is a polynomial of degree 0, that is a constant, then triangle f of x equals 0. Calculate triangle x squared and triangle x cubed. Prove that triangle h of x is always equivalent to dh of x by dx for any polynomial h of x. You should make it clear whenever you use one of the above rules in your proof. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started. Firstly, we'll set f of x equal to g of x equal to 1. Now, the triangle of f of x g of x is equal to the triangle of f of x times g of x plus f of x times the triangle of g of x by rule 4. We therefore have the triangle of 1 equals the triangle of 1 times 1 plus 1 times the triangle of 1. The triangle of 1 is therefore equal to 2 times the triangle of 1, and so the triangle of 1 is therefore equal to 0. We can then use rule 3 to say that the triangle of k is equal to k times the triangle of 1, which is still 0. Now we can find triangle x squared. This is equal to triangle x times x plus x times triangle x by rule 4. This, by rule 1, is equal to 1 times x plus x times 1, which is 2x. Similarly, we have triangle x cubed equals x triangle x squared plus x squared triangle x by rule 4. This is equal to x times 2x and x squared times 1 by rule 1 and the result for x squared that we proved above. Simplifying this gives 3x squared as our result. Now we'll move on to the final part of the question. By rule 2, triangle can be applied to the terms of any polynomial separately, so we only need to consider a generic term on its own. Let's have h of x equals cx to the k. We know that the derivative h primed of x is ckx to the k minus 1. We'll now try to evaluate triangle cx to the k. By rule 3, this is equal to c triangle x to the k. What we now need to do is we need to prove triangle x to the k is kx to the k minus 1, and we'll do this by induction. The basis step for this induction will be k equals 0. This has already been proved above. The assumption step will simply be to assume the case where k equals n. We'll call this assumption assumption 5. We can now induct our result for k equals n plus 1. The triangle of x to the n plus 1 is equal to the triangle of x times x to the n. This, by rule 4, is equal to x to the n triangle x plus x triangle x to the n. By results 1 and 5, this is equal to x to the n plus x of n x to the n minus 1. This will expand to x to the n plus n of x to the n, and this is equal to n plus 1 of x to the n. We can now conclude our induction and say that by induction, triangle x to the k equals k times x to the k minus 1, for k is a non-negative integer. We therefore have that triangle cx to the k equals ckx to the k minus 1. So triangle h of x is equal to h primed of x for all polynomials h of x. And that's our answer. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.